Good morning, ladies and gentlemen. We're going to do 8.5 today. We're going to be talking about partial fractions. It's also called partial fraction decomposition. We're going to review this concept from pre-calc, and then we're going to use our PFD to help us integrate rational functions. Alrighty, so what I'm going to do first is just walk through a couple of examples, and then we will talk about its application to calculus. So I think it's going to be pretty obvious, but we need to go back and review our math first and then some calculator work. So let's say I'm given a rational expression 1 over x squared minus 5x plus 6, and for calculus we'll pretend that it's an integral. And an easy way to manage this, details, would be to separate this into into its factors. So I'm going to factor it as x minus 3 and x minus 2. And then I'm going to do the partial fraction decomposition. So I'm actually not going to manage the integral. I'm just going to manage the rational function. So I'm going to write this, and then I'm going to write its factors. So if you'll remember, when I do a partial fraction decomposition, I'm going to split a function into, for right now, its linear factors. And I'm going to put a capital letter A over that linear factor, and I'm going to put a capital letter B over this linear factor. The next step would be to kill the denominators. So I'm going to multiply both sides of the equation by the lowest common denominator in its factored form. So then I'm lazy because I just wrote this on one side, but I'm in essence multiplying this by the whole equation. So it kills this denominator, and I get 1 is equal to, the A has the x minus 3, so I'm going to multiply it by x minus 2, and then the B has the x minus 2, so I'm going to multiply it by the x minus 3. Now, if you'll remember from way back in the dark ages, which was years ago for us when we did pre-calc together, there are two different ways to do this. It creates a system of equations, and I could solve the system by hand, but it's way overrated because at this point the system is a means to an end. So I'm going to go back, and we are going to use matrices. So I'll show you how I put it in my calculator, and then we're going to solve a matrix with the matrix operation RREF. And if you'll remember, it looks like this. So I'm going to put an A there, and 0, 1, 0, and then a B, and then a 0, 0, 1, and a C. So when I do RREF in my calculator, it creates an identity matrix, which is what this piece is. And then notice the way that I write my equations, these are the solutions for the variables, and then I just substitute those in and I'm done. So sometimes it's more efficient to solve the system by hand. I have an example like that today. But for right now, I'm going to remind you how to do this with matrices, because sometimes when I split up my fractions, it gets to be quite entertaining. So I'm going to write AX minus 2 times A plus BX minus 3B. And so if you'll remember when we do this, I'm going to group like terms together. So I'm going to group my x things together. I'll do those in blue. So I'm going to say AX plus BX is equal to, and then I'm looking over here at the left-hand side of the equation. There's no x term, so I'm going to write 0x. Okay, and if you'll remember, the coefficients of those guys are 1. Well, the next group of terms are my constants, which would be those guys. So I'm going to write a negative 2a minus 3b is equal to 1. And then I'm going to take this information and I'm going to turn it into an augmented matrix. And if you'll remember, an augmented matrix is just a matrix that reflects the coefficients. Remember, they all have to be in the same order, and it has the solutions included in the matrix. So that's what makes it an augmented matrix. So I'm going to have 1, 1, 0, negative 2, negative 3, and 1. So this is going to be my augmented matrix. So let me whip out my handy-dandy calculator. I think you can see that. Okay, I'll scoot it over just a little bit. So I'm going to do second matrix, and then I'm going to edit A, because I like to manage A. This one is a 2 by 3, and then I enter my matrix 1, 1, 0, 2, negative 3, 1. You always want to make sure that you check your data entry, because that's where we usually screw stuff up, and if you make a wrong entry, then that means your whole system is going to be wrong. So then I'm going to quit. I'm going to go back to my matrix button. I'm going to go do math, and then I'm going to go way down and do, oops, I missed it, my RREF, and remember that stands for Reduced Row Echelon Form, which is an identity matrix with the answers on the right-hand side. I'm going to hit enter. I have to tell it which matrix I want to play with. I do A because then I don't have to work quite as hard. Hit enter, and look, hallelujah, there are my answers. So then if I do my math, and I must have made a mistake, so I'm going to go back and look at my matrix and make sure I didn't screw something up. 1, 1, 0, 2, negative 3, 1. And I think I'm good. Oh, no, I'm not. I think I have a sign mistake. Yes, I do, because I covered it up with my calculator. So I'm going to go back in, and I'm going to edit this guy. He's supposed to be a negative 2. And then I'm going to quit. Second, enter, go. So much better. And my solutions are 1, 0, 1, 0, 1, negative 1. So if you'll notice, this is the identity matrix. Here are your answers. So that tells me that A is 1, B is a negative 1. Okay, get my handy-dandy calculator out of the way. So then I can go back and rewrite my integral and my decomposition. So my integral of 1 over x squared minus 5x plus 6 dx is equal to A, 1 over x minus 3, big parentheses, and then plus a negative 1 over x minus 2, big parentheses, dx. And then it's really easy to integrate. The hardest part about the rational expression is pulling out those fractions to make the problem easier. And then it's just straight U substitution and piece of cake. All right, there are a couple of other things that we need to remember about our decomposition. So you can't see it, so I'll rewrite it. So I'm trying to break my original rational expression up into linear factors, but I have a couple of things that happen on occasion. So let's say I have this situation, right? And this is a completely different example. Well, then when I split this little guy up, he's going to be A over x plus 2 to the first, and then it would be B over x plus 2 to the second. So if you have anything that has a repeated power, you have to progress through from 1 to 2 and then however many you had. The other situation is, somebody loves me. Let's say I have x squared plus 4, okay? This is irreducible over the reals, E-D-U-C-I-B, that's a weird word. This is irreducible over the reals, which means that when I try to solve this, I get an imaginary number. So when I have an irreducible factor, I have to split it up into ax plus b, and then this would be over x squared plus 4. So those are the additional things that you have to remember about setting up our partial fraction decomposition. So I just want to do now several examples that help us work through this process. And I was going to write down the rules about how to do this, but I think by the time I go through a couple of examples that you'll be good to go. All right, so let's start our next example. This one's a little bit more entertaining. I have 5x squared, I'm going to go ahead and write it as an integral, plus 20x plus 6 over x cubed plus 2x squared plus x, and then I have dx. And that's just yucky. So I do want to be careful and factor the numerator. I happen to know on this one that it doesn't factor with something that can reduce. If you could make the problem simpler as you get started. So if I factor my denominator, I'm going to take out an x, and I'm going to get x squared plus 2x plus 1, and then this factors to be x plus 1 quantity squared. So then as I write my partial fraction decomposition, I'm going to do a over x. Remember, I have a repeated factor, so I have to split that up, and I'm going to have x plus 1, and then I'm going to have c over x plus 1 squared. I'm going to multiply, and I kind of pulled everything out of the radical, by my lowest common denominator, and you need to write that in its factored form because it makes your life easier. Oops, I don't need that guy. We'll scribble him out. Well, if I multiply, if this is my lowest common denominator, all of that stuff goes away, and on the left-hand side, I get 5x squared plus 20x plus 6, and then I'm going to have a times, he has the x, so he needs to have the x plus 1 quantity squared. The b has one of these, so it needs one, and it needs one of those. And then for the c, it has both of those, and it just needs the x, okay? So I need to distribute on this side. One of the things that I do before I start is I distribute my factors, so I'm not doing too much math on the run because I tend to make stupid mistakes. And this would be x squared plus 2x plus 1, okay? So then if I distribute on the right-hand side, I get ax squared plus 2ax plus a plus bx squared plus bx plus cx. And then we're going to set that equal to the left-hand side of the equation. So now what I'm going to do is I'm going to start collecting my squared factors first because I'm a little bit anal. So I have that guy, there's no cx squared, and this guy. So I'm going to write my matrix. This is ax squared, bx squared, a 0cx squared, and it equals 5x squared. And then I cross them off as I use them so I don't try to screw stuff up and reuse it. Well, the next ones are going to be my linear factors. This one, this one, this one, and this one. So I'm going to write 2ax plus bx plus cx is equal to 20x. And then I'm going to do my constants. A, there's no b and no c. I still have to write it down, though. If I'm going to use it in matrix form, I have to put in placeholders. So I'm going to have a plus 0b plus 0c, and I forgot to mark these guys off because I used them, is equal to 6. Now at this point you'll notice that a is equal to 6, and I could use that information and solve this system by substitution or elimination, but bag that, I'm going to use my calculator. So now I'm going to write my augmented matrix. I have 1, 1, 0, 5, 2, 1, 1, 20, 1, 0, 0, 6. I'm going to put that in my handy-dandy calculator, and when I do all of that math, and I'm assuming that you can do this because you're brilliant, I'm going to write a is equal to 6, b is equal to a negative 1, and c is equal to 9. So now I can split my given integral up, and it looks fairly polite. So my original integral of 5x squared plus 20x plus 6 over x to the third plus 2x squared plus x dx is equal to 6 over x plus a negative 1 over x plus 1. Move my water over so I don't knock it over. And then plus 9 over the x plus 1 quantity squared. And then make it look pretty. Put that little guy, and now we're done and ready to integrate. So partial fraction decomposition is really a helpful tool, and I am a little bit lazy and don't like trying to solve the system because I can do it by hand. Alrighty? Or sorry, I can do it in my calculator. Way more fun. Alright, so for our next example, I need some real estate, so let me just start a new sheet. So for this one, we're going to have the integral of 2x cubed minus 4x minus 8 over, and then I have x squared minus x, and then I have x squared plus 4. And in these examples, none of the factors remove because the book has done that on purpose. So without being too lazy, I would always make sure that you factor the top and make sure that none of your factors remove, because if they remove, you've just shortened the amount of work you have to do. Alrighty, this one can still be factored more, and I'm going to do that, and I get x minus 1. This one is irreducible over the reals, so when I set up my PFD, I'm going to have a over x plus b over x minus 1 plus cx plus d times x, my bad, there we go, x squared plus 4. Alrighty, so now remember the next step is to multiply both sides of the equation by the lowest common denominator, and I'm going to write it out in its factored form because it's easier to see what I need, okay? So if I do that, alright, so now I'm going to get 2x cubed minus 4x minus 8 is equal to a times x minus 1 times x squared plus 4. The b is going to be multiplied by x, and the x squared plus 4, and the cx plus d. See why you don't want to have to solve a system by hand? This is kind of yucky. And then I have, he has that one, so I get x squared minus x, okay? Whew! Now I just have some math to do, alrighty? If I expand this guy, I get x cubed minus x squared plus 4x minus 4, and then this one's going to be x cubed plus 4x, and then this one's already done, okay? And I just do that because if I manage this separately, I'm less likely to make as many stupid mistakes, right? So I'm going to write 2x cubed minus 4x minus 8 is equal to ax cubed minus ax squared plus 4ax minus 4a plus bx cubed plus 4bx. And then when I do this one out, I get cx cubed minus cx squared, plus dx squared minus dx. Ooh, that's a lot of stuff. And notice, thank you, sorry, notice I have cubed things, squared things, linear things, constants. So I'm going to write a bigger augmented matrix. So I'm going to start collecting my terms. My cubed things are this. There's no d one, so we have to put in a placeholder. So I get ax cubed, used him, plus bx cubed plus cx cubed plus 0d equals 2x cubed. So that guy's gone. Now I'm going to do my squared guys. I have this one. I have no b squared. There's a c. There's a d. And notice I don't have a squared thing over here. So I'm just going to write a 0 because zeros aren't bad. So I get a negative ax squared. There's no 0b x squared. There is, oops, I forgot to mark him off. I used him, minus cx squared plus dx squared equals 0. And remember, that's really not that big a deal. Now I'm going to do my linear guys. That one, no c, there's a d, there's that one. So I do 4ax plus 4bx. There's a 0c, and then minus dx equals a negative 4x. And then my last one, so I used that one, that one, that one, that one. My last ones are my constants. So I have a negative 4a. I use that guy. No b, no c, and no d. And then I have a negative 8. So again, I'm going to get that a is equal to 2, but at this point, did I do that right? Negative 4a, a is, I think I wrote something down wrong. Yeah, I did. My bad. This is plus, this is plus, this is plus. Whew, helps when you write the problem down correctly. All right, so now when I turn this into my augmented matrix, I'm going to get 1, 1, 1, 0, 2, negative 1, 0, negative 1, 1, 0, 4, 4, 0, negative 1, negative 4, negative 4, 0, 0, 0, 8. I'm going to run this through my calculator, so I enter my data. Again, you need to be really careful with your data entry, just like you need to be careful writing down the problem. Because if you enter it badly, then you're going to get bad answers. So then I get A is a negative 2, B is 1.2, C is 2.8, D is 0.8. If you wanted these values in fractions, remember that you can math bracket, and that will turn them back into fractions, but it's 6 of one, half a dozen of another. So now I can rewrite my integral. So my integral of 2x cubed minus 4x plus 8 over x squared minus x times x squared plus 4 dx, I'll move it up, I know you can't see, is equal to, now I'm going to put all these guys in, a negative 2 integral big parentheses over x plus 1.2 over x minus 1 plus 2.8x plus 0.8 over x squared plus 4, close those guys, dx. And yes, it's a wee bit tedious, but it's still really pretty simple to integrate. Alrighty, so I think you get the general idea, and I would say that that's probably enough examples because we've done repeated factors, we've done irreducible factors, and I think you understand the process. So that is it for today, and I will see you tomorrow.